Okay, this lecture is over a protocol called SNMP. SNMP stands for Simple Network Management Protocol. Its purpose is to remotely monitor and on occasion administer devices that are on your network. The first version of SNMP was created in 1988, and there are a number of RFCs. I think all the ones we've seen so far, as far as protocols go, the majority of them have one RFC that may over time be replaced with updated RFCs. We may have seen one protocol that had two RFCs. This one appears to have around 34. So that is a lot, but that's the way it is. 5 years later, in 1993, version 2 came out, and it is described in the 12 RFCs listed there, 1441 to 1452. And then the current version is version 3, which came out in 1998. And here's a strew of, looks like maybe 13 different RFCs, or actually 16. So there are lots of pieces to SNMP, and therefore it's broken down into a lot of RFCs. As far as the operational model is pretty simple. We have something called the manager that keeps track of devices and alerts and that type of thing. And entities are usually devices out on the network that you want to monitor. So that's the operational model. As far as the components, we have the SNMP protocol itself. We have something called an MIB, which is a management information base. It is a collection or database of objects that can be monitored or managed through the system. We have something called an SMI, which is the structure of management information. And this defines objects in the system, notifications that we can have, and modules that are used to process the data. First time I saw SNMP years ago, you had something, I think back then it was called the community string, but it's just a sequence of numbers. And you had lots of documentation that talked about, this object does this object does that, and it was just a jumble of numbers. And at first glance you're like, what in the heck is this? How am I supposed to understand it? Well, we have something called the object name hierarchy, and once you see this and know this, you hopefully at least better understand what that big string of numbers is. So what I'm going to show next is figure 66-2 from your main textbook. That looks like this. So we basically have a hierarchical or tree structure that talks what we're talking about. So at the very first number, a lot of times that's a 1 that stands for ISO, etc. So I'll show you one of these on the next page, kind of going through this chart or a similar chart. So the object I showed before was 1.3, 0.6, 0.1, 0.2, 0.1, 0.1. So if we go back and look at the table, from the root, this is something to do with ISO. It is an identified organization. It relates to the DoD, in particular the internet. It's a management thing. It's an MIB for a system. That may not help you actually know what type of object this is referring to, but at least hopefully it helps you understand what the string of numbers is. As far as the message format, This is the message format we have. The first 6 things, or actually 5 things, are fixed length, and after that we have 5 variable length things. So that's what the different fields are, and pictorially showing their size. Going through them one by one in order they appear. We first have the message version, which is 4 bytes, and the current version for 20 plus years has been version 3. So this is going to be a 3 for quote modern implementations of SNMP. Next, we have a message identifier. As always, when we have an ID, this is often a unique number that the receiving device, or manager in this case, can reply back and include that message ID so that the response can be matched up with the request. There is a maximum message size. This is the maximum size that the sender can receive back in response to a message. There is a minimum of 484 bytes, but it goes up in the millions because that's a 4 byte value. Continuing on, the next thing we have is the flag fields. The flag field is 1 byte, 8 bits. The first 5 bits are reserved. The 6th bit is something called a reportable flag. If that's set to 1, the device that receives this message must reply back. Next is a privacy flag. If it's set to 1 or true, encryption was used. And then the last bit is the authentication flag, and it is set to 1 or true if authentication was used. Continuing on, the next thing we have is the message security model. This specifies what method was used. As far as security, the default is user-based. Often user-based is a user ID and or password. The parameters for the message security is a set of fields that are related. It will be different for each of the security models that might be used. Okay, evidently I duplicated that. Sorry about that. Context engine ID identifies the application that the PDU will be sent to for processing. We have a context name, which specifies what context is associated with the PDU in the message. We then have control fields that describe what PDU is to follow and is used to communicate between SNMP entities. And then we have variable bindings, which are a set of descriptions of the MIB objects, and this is a set of name-value pairs. This is an example of a monitor dashboard. Basically what happens is you have SNMP manager running, it collects data, and then you usually have a dashboard or display that is used to give you information. So all the cryptic, complex stuff about the protocol is kind of hidden and taken care of for you by most SNMP software, because most of those have a really nice dashboard like we see here. And that is the discussion of the SNMP protocol.